In our previous lecture, we discussed about the scalar product or dot product. Now, we will discuss on vector products or cross product. Here, the vector or cross product of any two vectors. So, this is a vector P and this is a vector Q. So, the cross product of P and Q, it will be P cross Q. And here says that the product of any two vector is another vector. So, where we multiply or this P and Q, the cross product give us a new vector. And the magnitude of which is obtained by multiplying the magnitudes of the constituent vectors. So the magnitudes of the constituent vector means the magnitudes of P vector and magnitudes of Q vectors with the sign of the angle between them. So let us consider the sign of the angle between this P and Q is theta. So it says that the sign of the angle between them. So the sign of the angle between them will be sine theta, and the direction is perpendicular to the plane containing the vectors. So the plane containing the vectors means it will be like upwards. If as it is a two-dimensional, so you have to imagine your power. So the resultant vector must be perpendicular this point to upwards or perpendicular to this point in downwards. We will discuss when it will be on upwards of perpendicular plane and when it will be downwards from perpendicular plane. As it is a vector, so it will have a vector sign. To maintain this, to obtain this vector sign, we use an new term which is known as eta. So as eta is a unit vector, so this whole term must be an must be a vector quantity. So when we multiply two vectors, this P and Q vectors, and we obtain a new vector that is known as vector product or cross product. So this is the formula how we can obtain the cross product or vector product. Here we can find that theta plays an important role. For different types of angle, we'll get a different types of uh, result. So if the theta equals to 0 degree, then P cross Q will be 0. We know because sine 0 degree equals to 0. So when two vectors P and Q are parallel to each other, then their cross product must be 0. This is an special case we have to remember. When two vectors are parallel to each other, then their cross product will be 0. Now, if the angle between them is 90 degree, then P cross Q will be the magnitude of P and the magnitude of Q, and eta is the direction of this resultant vector. So it will be the maximum. It will be maximum. It means when two vectors are acting perpendicular to each other, then their cross product will be the maximum value. So this is the, so we found that when the theta equals to 90 degree, the cross product will be maximum. What will be happen when the theta equals to 180 degree? Then we know sine 180 degree equals to 0. So the cross product will be 0. The cross product will be 0 of these two vectors. It means when two vectors are acting opposite to each other, then opposite to each other means then like this, then their cross product will be 0. Their cross product will be 0. So this is the three cases where theta plays an important role. And we have to remember when theta equals to 0 degree, then their cross product must be 0. And theta is 0 degree means they are parallel to each other. And when theta is 180 degree, the cross product also be 0. But this time, these are parallel to each other, but in the opposite direction. In the opposite direction. Now, we'll talk about cross product of unit vectors. What is unit vectors? So, first of all, let me draw a three-dimensional frame. This is x-axis, this is y-axis, this is z-axis. And we know the unit vector along x-axis is I cap, unit vector along y-axis is j cap, and unit vector along z-axis is k cap. And they are perpendicular to each other. But we know when the angle is 0 degree, then the cross product must be 0. So when I cross I will get 0, when j cross j will get 0, when k cross k will get 0, because the angle between these two I is 0, so their cross multiplication will be 0. But what happened if we multiply I cross j or I cross k or any combination of that? For that, we will draw this kind of symbol, and this is I, this is j, and this is k. When we rotate this thing as clockwise, then we will get the positive signs of this unit cross production of this unit vector. That means when I cross j will get k vector, when j cross k will get I vector, when k cross I will get j vector. But if we rotate this thing in anti-clockwise, then we will get the negative sign of that. That means I cross k will be then minus j, k cross j will be then minus I, and j cross I will be minus k. So we will remember the unit production of cross product in that manner. So let me give me some time to remove this. Now, if A is a vector and the vector value of A is some AXI plus AYJ plus AZK, and B is also a vector, and the X components of B is BXI, Y component of B is BYJ, and the Z component of B is BZK. Now we want to find the cross product of these two vectors A cross B. Then what will happen? How can we find this thing? To find this A cross B, we will determine the value of AX. No, that will not be A. There will be I, then there will be J, and there will be K. And for I we will get AX BX. For J we will get AY BY, and for K we will get AZ BZ. When we determine this determinator, the result will give us a new vector. So in that manner, we will find out the cross product of these two vector A and B. Now, what will be the magnitude of this 2 vector A cross B? The magnitude of the two vector A cross B will be modulus of A cross B, and the value will be some like ABX square plus ABY square plus ABZ square. Like, and why we can find this ABX, ABY, ABZ. The ABX, ABY, ABZ, we can find this by this new vector. When we calculate this determinator, then we will get a new vector, and by the help of this new vector, we will find the modulo of this, the magnitude of A cross B. Now, we forget to discuss one thing. The thing is the how we can find out the angle between them. For this, we will use a law which is known as right hand rule, which is known as right hand rule, or we can say that the right hand screw rule. Right hand screw rule. So it says that if we make an angle in the anti-clockwise, like in that case, we find out the P cross Q. We find out P cross Q, and the angle is in anti-clockwise position. Then the rule says that the resultant unit vector will be the perpendicular upwards from the plane. From the plane. If I draw this in that manner, uh, suppose this is a plane, this is a plane, and here P vector is working, and here Q vector is working, and the angle between this P and Q is theta, and we want to find out the unit vector of this cross product. The cross product means P cross Q. As we make an angle theta in anti-clockwise, so the angle will be in the upwards direction. Upwards means this is the angle. If we want to find out Q cross P, what is now if we want to find out Q cross P, then the angle direction will be, oh, let me correct this. This is P vector, this is Q vector. No, this is Q vector and this is P vector. Pardon me for my mistakes. In the previous example, we cross P cross Q, and the angle is in anti-clockwise position. So the perpendicular will be the upwards from the plane. Now you want to find out Q cross P. We want to find out Q cross P. In Q cross P, the angle will be remain theta, but in that now it is in clockwise direction. Now it is in clockwise direction. In that case, the unit vector will be perpendicular downwards from the plane. This is known as right hand screw rule. By this, we can find out whether it is the perpendicular upwards or perpendicular downwards when we calculate the cross product. That's all for today's video. In our next lecture, we will solve some math equations. Be with us to get new videos like this. Subscribe to our channel and like these videos. Thank you.